What up, dudes? Can you hear my voice? Can you see my face? You notice? And can you hear the words that are coming out of my mouth? And nobody understands the words that are coming out of your mouth. You guys don't know that movie because you guys are young. Do you? You guys know what I'm talking about? If you know it, you know it. All right. If you're in, you're in. All right. Anyway, let's get started. I'm gonna try this out, and I'll tell you what. You guys start working on those things already. I want you guys to throw up the guess. We're doing problem number 1. In fact, here, you guys can have a few other pages here. You guys can have them. Take them. We're going to do problem number 1, and we're going to try this out together, and we're trying something new today. I'm going to send you guys a link. I want you guys to log in to the Google presentation. If you're already in there, then don't worry about it for now. And I want you to try something out. All right, go to that Google presentation. I want you to try something. I want you to take your name, and I want you to tell me, I want you to put your name by which of these symbols, or which of these equations does this graph represent? And you guys can work together. Well, those of you online, just move your name into there and see what you guys got. We're doing this paper thing. This one right here, the graph. I want you to look at the graph. I want you to say, this graph looks like, or what's the equation for this graph? Move your name. Take your name. Like Brandy, which one do you think it is? Which one of these do you think it is? I'm dragging your name. You tell me which one. The answers are up there. That's why I gave you a worksheet. So move your name, grab your name, go to page 2 on the presentation, and for you guys it's page 1. All right, here, you need one? There we go. So which one do you want to put your name by? Which one? And don't cover up the answers, please, because then no one else can see. What do you think? Which one is it? You mean there's no answers? The answer's not there? Tell me that. No, it's J? Oh, that's junk. The answer's not even there. Suckers. I'm sorry, you guys. All right, let's try number 2. Let's try it. Do number 2. Go to slide number 3 and see if that works. Which one is this? Randy, which one do you think it is? All right, which one is this? No, they left for a field trip. I think so. They went to like good stuff. Wait, Ted, you got to move your thing to an actual place, not the graph. There we go. All right, come on, everyone else choose. What do you guys think? That's awesome. That's exactly. Which one is it? No, it's F? Yeah. It's J of X, though. Are we cool? Looks like you guys went to herd mentality. All right, let's try number 3. I think this is kind of fun, right? Like we're doing pretty good. Then work together. Start asking each other. We're doing problem number 3 together. Ted. Yes. And as I said, if you guys participate today, I'm giving you guys, this is part of participating. I'm going to give you 5 points extra credit for the end of this class, but don't tell anybody that. Oops, I put this on the recording. So that's right. If you didn't show up for class, missed extra credits. That's right, YouTube, looking at the archive. What's up? Nalu and Tatiana, I know that your computer's slow. I apologize. I'm going to give you that extra credit anyway. Don't worry about it. No, and I'm giving extra credit to everyone who showed up and to everyone who showed up for WebEx. So everyone here that is in the vicinity of my voice gets extra credit when we finish the class. Got it? Are we cool? Yeah, we're on 3. All right, do problem number 3. It's on page 4. There is a there's Raimana, and there's an anonymous frog stuck on on problem 2. I want you to go to problem 3. There we go. Raimana's on there. Okay, and the anonymous frog moved. Nalu, I had to turn off your audio because you were going crazy. You sound like a robot from, what you call it? A robot from Star Wars. By the way, move your things. What do you guys think? Are you guys getting this? Is this like easy? Is this hard? Like this used to be like the old school matching game. What? This used to be like the old school matching game. All right, I'll tell you what. Let's do this. Wait, okay, wait. Like we're going through this and we're getting really good at this, but Lonnie's saying I don't get it, and I'm gonna stop. And I'm actually saying I'm not pointing it out and saying boo-hoo to you, Lonnie. Look how you don't understand this. I want you guys to look at me. I want you guys to concentrate. Look. No, I want you to concentrate. When someone says they don't understand, let's be super supportive of them. Yeah. Right? Like, no, we're cool with that, right? So here's what's going on, Lonnie, and not just to Lonnie, but actually to everybody else. Here's what's going on. What you're looking at here is basically the only thing we really need to look at here is where does this thing cross the x-axis? And I'm looking at -3 or -1 and +3 for this graph right here. You guys got it? And so the way that we've set this up, in fact, let's see who answered this question. What did you guys get for question 3 is, okay, so this is what you guys say the answer is. It's x + 1, x - 3 is the correct one. Yes. And how did you guys get that? Where did you guys get that from by looking at this graph? Yeah. Because it's at +3 and -1. So it's kind of like the opposites. It's kind of like the opposite of what's going on, right? Are we cool with that? Lonnie, does that make sense? We also know that this thing opens up positive. This thing opens upwards. Yeah, go for it. We also know that this thing opens up upwards. So we know that there's going to be a positive sign in front of it, or there's no sign in front of it, which implies a positive sign. If there were a negative sign in front of it, this thing would open downwards. Are we cool with that? Yes. All right. Everyone good? Now, if anyone needs to ask me questions, please stop me. And please don't feel bad about asking me. Got it? All right. Oh, do you guys understand this thing enough for us to move on? Are we cool? Yes. All right, then let's do the next one. I'm going to start up on my lesson for chapter 6. We're so cool. All right, pull up in quad 6. We're going to get started on this party. Oh. Yep, quad 6 already. We're doing it already. We're all done with that thing. That was warm-up. That was warm-up. This is the big kid one. You ready? Oh, God. Graph this. Graph number 2. We got this. When the other twin comes back, we all got this. No, you guys can do it. Graph number 2. Try graphing it on your papers at home. Graph it over here.
I know where the points are.
All right, fine. Where are the points? You can tell me.
Yes.
-4 and what? And what? We're doing number 2. It's at both -1 and -5. All right. Here's what's going down. All right. So basically, you put a dot here and a dot here, right? And Hilani, maybe you guys didn't understand what we did the last lesson. This is from Quad 1. This is stuff from Quad 1 still. But what we did was we're basically asking ourselves, when does this thing cross the x-axis? What we're trying to do is we're trying to figure out what is the solution for this parabola, right? And in order to figure out the x-intercepts, what do you do? X-intercepts. What do I do? Y equals 0, exactly. If you want the x-intercept, y equals 0. But in this case, you don't see a y, do you? You see the f of x. But I told you that's the same as y. Exactly. Dude, you guys got it. All right, so what we're doing is we're saying this thing equal to 0, and we have -x plus 1 times x plus 5. And what I've been asking you to do is I'm asking you to solve this equation. So when does this times this equal 0? Well, either this equals 0 or this equals 0. You guys remember this? This is from chapter 5.
Yes.
So we got x plus 1 equals 0 and x plus 5 equals 0. Therefore, x equals -1 and x equals -5. Ilani, that's kind of the explanation as to why we were able to look at those points and immediately tell you what the equation was. Right? Or you could look at the equation and immediately tell where the points are. They're kind of like the opposite signs of whatever's in there, inside the parentheses. Are we cool with this?
Yes.
Good. Awesome. I'm glad. All right, now, if I ask you to graph this, where does it how does it open up? Does it open upwards or does it open down? Is it a happy face?
It's a sad
Or is it a sad face?
Sad face.
It's a frowny face. Wow, how can you tell? Because that negative right there. Can you guys see the board? All right, good. But you can see the like writing. All right, so it's a down. It opens down, so we know that it's going to open like this. You cool? Now I have a question for you. How do we figure out how high it goes? No, you can't say what I was telling you about because. How would I figure out how high it goes? All right, the highest point on this graph is going to be what? What do we call that? The vertex. Good. How do we find the vertex?
The y vertex?
Yes. How do we find the vertex?
The x vertex.
Well, what is the x vertex? What do you mean by x vertex? You think that the vertex occurs when x equals -3. Is that what you're telling me?
Yes.
Exactly, because it's right in between -1 and -5. That's how you do it. You take the x, where does the x vertex occur? It's at -3. And then what you do is you plug in -3 into your original equation. And therefore you're good. So, if I plug in -3 into there, I have -3 plus 1 times -3 plus 5. And this becomes -2 times +2. So, what is -2 times +2? All right, what is -2 times +2? -4. And then I'm going to negative that. +4, which is why it crosses at +4, which therefore my graph is a little bit off. The actual graph should probably look something like this. Yes, you have 2 gold stars. Here you go. All right, let's see. Gold Star John. I'm gonna even write that down. I'm gonna even make it gold. Oh, JH. I'll give you 2, right? There we go. Sorry, John. That's not worth extra credit. That's worth a thumbs up for me, though. All right. So check this out. Are we cool with this? You guys understand? This is from Quad 5. This is like what we did in the past. But guess what? What we did before is totally going to come into play with what we do now. All right? All right, let me show you guys something else now. And this is actually pretty cool. Actually, I was thinking about doing this one. And you know what? We'll play this game because I think it's kind of fun. Turn to the next page. It's page 2. And what we're going to do is we're going to play the game of Connect the Dots. You guys played that game back when you were in kindergarten, right? Connect the Dots? Good, let's do it. I'm going to do it now. You ready? And I have a point. I have a reason why I'm doing this, okay? It's not just a fun game we're doing. I'm going to do the first 2 for you. I'm going to draw the parabola that these dots connect. There we go. And there we go. Do you guys agree?
Yep.
That's pretty simple? Yep. Do the rest of them on that page. Should take you like a couple of seconds, not even a minute. All right, I want everyone to do it. Are you guys good? All right. All right. So we're on Quad 6. We're on the worksheet, and we're on page. What is this? Page 2.
Yes.
And we're connecting dots like we did back in kindergarten. All right, here. Okay, let's go through the answers, and you guys tell me whether or not you guys agree with this. Got it? All right, there's my phone. All right. So is that what you guys got? Something like that? I'm sure that you guys got something a little prettier, right? I mean, that's what you guys got?
Yeah.
Wait, you didn't get one? Okay, all right, what about for this last one, for the second to last one? Something like that? All right, for the last one, I got this. Is that what you got? Really? Everyone got that?
No. I didn't.
No?
No.
Wait a second. I'm drawing a parabola here. It's really easy. You guys, we all agreed on like the first 5 answers. What's going on?
We only had 2.
Right. So what's the problem here?
We don't know.
Okay. So like some of you got this one. Some of you might have even gotten this one. That could have been an answer, right? Did anyone get that?
Or skinnier.
Or skinnier? How could the red? Oh, I see. I see. You mean like this, where like you have a dot here and a dot here, and the thing goes like this. It's a really skinny problem. Oh, okay. You could make it like, dude. There's like so many possibilities. So here's the problem. It's kind of like that same question. Draw a line going through these 2 points. Easy, right? Right? Draw a line going through this 1 point. There's like a million lines I could draw, right? Same thing with a parabola. How many points do we need to define a parabola? At least 3. We need 2 points and definitely a vertex to really get a solid parabola. If we only have 2 points, then we kind of can know what the parabola looks like, but we don't really have it locked in until we have that 3rd point. Are we cool? And that's the point that I was trying to make with this connecting the dots. All right. Here's what I want to do. I'm going to take a look at this because I think this is really important. I'm going to go over to Desmos. I'm going to plug in this. In fact, I hated the equations they gave you, so cross them out on page 3. You guys turn on page 3. All right, you guys ready? I'm going to graph this one. Negative x squared plus 6x minus 5. So let's go over to Desmos. I think I already have it in there. All right, let's make sure I got it. Negative x squared plus 6x minus 5. This is a parabola. Everyone agree? This is like the first thing I remember teaching you guys. This is, I'm just making this up. So pull out a scratch piece of paper if you guys need. This is negative 6x squared plus 6x minus 5. Got it?
Yeah.
How did I ask you to graph this old school? How did I ask you to graph this like way back when? Do you guys remember? What I asked you to do is probably do something like this. Once you see it, you're going to be like, oh, I get it. X, Y, and then you plug in a bunch of stuff, and then you calculate it out, right? And then you make the little dots everywhere, and then you connect the dots, right? Okay, that was the first thing I remember teaching you guys, like 5, 6, 7 weeks ago. That's the baby style. We're gonna get into the big kid style now, but do you guys remember how to make that graph? You plug in those dots and all of that kind of stuff, make a table. Now, I want you to take a look at this. If I were to ask you something crazy like this, do you guys everyone agree that this is the equation? Of course you agree. This is the graphing calculator. All right, I want you to look at this. Pretend I didn't give you that equation. Pretend I just asked you this. Here's a graph. What is the equation? What would you tell me? I'll give you a second. Write it down. And for those of you online, type it in. I want to see what you guys got. Here's a graph. What's the equation? Just think of this as a new problem. What's your thoughts? What's going on? What you think? Go for it. Throw it up.
Is it f of x?
Yeah, tell me.
F of x equals negative, and then in parentheses x minus 1, and then the next parentheses x minus 5.
Is that exactly right, Mana? -1 and -5. Those are where, well, that's not where it intercepts, but that's what you would put inside of those parentheses. X minus 1, x minus 5. Are we cool? Yes, sir. All right. And this right here is describing this graph, right? That would be the easier way to do it. That would be the easier way to go about it, right? So one way is I had the original way, which was x squared, was it minus 6x or no? X squared, negative x squared plus 6x minus 5, right? That's one form. Another form is this one, and that's the one you guys are down with, right? Why are you so cool with that? Because that's what we covered last week. All right, we just got through with that. All right. What did we cover before that? Do you guys remember this one right here? What if I told you this, where I have f of x equals a times x minus h squared plus k? Do you guys remember something vaguely like that? Yes? No? Yeah. This is the one you were really good at. Watch. If I wanted to build that graph, how is this graph different from a regular parabola? It's negative. It's flipped upside down. What else? I moved it to the right how much? 3 times. Agreed. Right, and I would put a -3 in there. What else? What else did I do? I moved it up 4. Exactly. Exactly, Raimana. Good. So I moved it to the right 3. I moved it up 4. Would you guys agree with me if I told you that this graph is actually negative x minus 3 squared plus 4? Everyone cool? Online, you got to tell me. Yes. Good. I understand. All right. So look. I just went over 3 different ways to describe the same graph. I have this form right here. We call this standard form. Got it? I have this form right here. I need some room over there. So what is this? Is green showing up good on that whiteboard behind me? All right. Not really? You guys want to switch to red or black? All right. This is called factored form. And then I've got this one on the bottom right here, and this is called vertex form. You guys got it? By the way, this is my lesson plan if you guys want to see it. I have it up there. All right. So you got the standard form, the factored form, the vertex form. And here's what I want to emphasize with you guys is they all describe the same thing. this is really just a secret code. Like, this is the same as that is the same as that. They're all the same. They look differently. They're like, you're still the same person each day, even though you change your clothes each day. You're just in different clothes. They look a little different, but they're the same thing. Got it? They're describing the same problem. Hopefully you change your clothes every day. All right. Check this out. What I mean by that is, if you were to FOIL this thing out, if I were to multiply all that out, I'm going to get this. And if I were to multiply all this out, I'm going to get back to here. You guys get it? So it's really just different ways of looking at it. Now, when I showed you the graph, you guys told me I would want to throw it in this form. Right? That's what you guys immediately told me. When I showed you the graph and I asked you, what's the equation? You said, oh, I think that maybe the easiest would be to put it in the factored form. To tell me the equation in the factored form, right? All right, let's talk about the advantages and disadvantages of each. Okay? What's the advantages of standard form? Exactly, because when you want to find the y-intercept, what do? X equals 0, and I can plug in x equals 0 into here, and that's cake, because x equals 0, negative 5. Y-intercept's at negative 5. Let's look at the graph. Boom, look, it crosses at negative 5. We cool?
Yes.
You want to know something truthfully? Beyond that, standard form kind of sucks. Like, I can get the y-intercept, whoop-de-doo. Beyond that, I don't know why they call it the standard form, because it's not really that useful. Here's the problem, though. Usually we give you a parabola that is in standard form. Ask me why. Or tell me why. I'd rather you tell me why than ask me. Can you guys tell me, why do you think that we usually give it in standard form? Why do we call it standard form? Because it's the most useless. I love Ted's answer, and I think that that's correct. No, because... Exactly. If I were to multiply this out, I would get something that looks like standard form. If I were to multiply this out, I would get something that looks like standard form. It's the most common form to put it in. This right here, I would have to do some work to put it into. This right here, I would have to do some work to put it into. But standard form, kind of useless. Negative y squared, or negative y, that's where it crosses. Are we cool?
Yeah.
All right, factored form, what's the advantages?
Finding the x-intercepts.
Online, what do you guys think?
I'm sorry.
No, it's all right. That was it. That was so short. It like came and left. Really? Oh, I had like the whole lesson planned out. I spent... Alright, fine. I spent a long time putting this thing together. By the way, for those of you who don't know, the people who came in to observe us, I like got this whole classroom just for that, and then they came in, and then they left. And I was like... Yeah, no, they do. They do. These people have emotions. Alright. Yes, you guys do get your extra credit. I'm just letting you know. But that doesn't mean you can mess around for the rest of the class. I mean, don't be just like all crazy on me. Let's go back to like regular class mode. Okay. So like, look, check this out. When we're in factored form, what's the advantage? We can get the x-intercepts. Cake, right?
Yes. Such cake.
It's basically the opposite of whatever's inside the parentheses.
Yep.
Right? There's also another good thing. See this thing right here? What does that tell us? It would move the parabola up or down. It would open up or open down. If there were a number 2 in front of it, what would that do? It would stretch it vertically, and then it would make it compress it. That same thing happens there. Are we cool with that? What's the advantage of vertex form? It tells me exactly where the vertex is. I can know exactly where to move the parabola up, down, right, left. Are we cool? Yes.
Did you bring gummy bears?
I didn't. I'm sorry.
Why am I even here?
I told you, I said I would bring gummy bears for like next year when I teach stretching and compressing for the first time. I don't know if I'll be your teacher next year, but I'll be a teacher next year. I don't know. All right, anyway. Yes, I'm going to call it the gummy bear theory. Hey, focus. All right. The advantage of vertex form is it puts it in, I can know exactly, move it up, down, left, right. We cool? All right. And then also, the negative, this number in front will tell me stretch, compress, open up, open down. Are we good with that?
Yes.
All right. Basically this. Here's what the whole lesson is going to be about today. This entire chapter is about doing this. We want to take things that are in standard form and turn it into factored form. That's what we're doing today. And you want to know what the next lesson after that, in fact, the next two lessons, lesson 7 and 8, is about? In fact, the rest of the year, all we're going to do is focus on... all we're doing is taking it from standard form and moving it into this form. So all you're going to do for the rest of the day, or for the rest of this week, or all we're going to talk about for this week is talking about moving it from this regular form into factored form. And that's that game. That's what we're doing. Yeah, so page 3, I don't know, I wrote in the standard form, the factored forms, but you guys can, I guess you guys should write this in. Write these things down over here by the standard form and factored form. We can talk about those real quick. So you write it down in your papers, on your quad 6 worksheets. Are we good? All right, the vertex form says a times x minus h squared plus k. And the factored form says a times x minus r times x minus s. I know that you folks would rather see numbers in there instead of letters, but the letters aren't bad. Like, let's talk about it. What does the h do? See this h? What does that do? It's where the x vertex lies. And why is there a negative inside there? The negative is accounting for that weird rule. That weird one where I say if it's x plus 5, that means you move it to the left 5. You guys remember?
Yeah.
And if it's x minus 5, you move it to the right 5. It does the opposite of what you expected. That's the right and left weirdness thing.
How do you find the vertex?
What? How do you find the vertex with a... Oh, you mean like if the vertex is at 0? Oh, that's really straightforward. It would be this. It would be like this. Watch. How's about x squared or x minus 0 squared plus 0, which is simply known as x squared. There we go. Vertex is at 0. I'm not even going to write the zeros because I don't need to. Because it's implied. Are we cool with this? You guys like understand this?
Yes.
Alright. Good. Then we're good with that? Yes, online? Alright. So, here's the problem. Here's the thing. What happens if we're given this form? So we like factored form, right? Factored form is really good. What happens if we're given standard form, though, and we want to graph it? Do we make a table? No, a table is annoying and takes long and it's tedious and I can make a lot of mistakes. And I would have to draw a graph to make it. What would you rather do?
Okay. May I answer this?
Yes.
If you wanted to go from factored to standard, or from standard to factored?
I'm talking about going from standard to Well, I'm talking about what happens if I'm given standard. What do I do?
So since you have to multiply exactly form to standard,
That's exactly it. But basically, what the answer is I have to factor it. If it's not in factored form, then put it in factored form. Like, just put it in factored form and it'll be straightforward. We cool? By the way, you guys weren't messing around while because I was kind of watching you, but I was kind of not. Were you guys like hitting each other while they were here? Okay. Why are you guys touching each other? Do you need me to move you guys? All right, just all right. So check this out. Hey, that all right? Fine. All right, turn to page 4. Here's what we got. Do you guys know how to do this problem right here? Multiply that out. Do you know how to do that? You're looking at it like, why don't I do this? Why don't I do this? How's about this? 4 times x plus 3. Do you guys know how to do that?
Yes.
How do you do it? Right. 4x plus 12. You distribute that sucker in. Are we cool? So how do you do this? 5x squared times 3x plus 4. That would be 15x cubed 20x squared.
Yeah, because there's no x.
Are we cool?
Yes.
You guys good? Alright, I will. In fact, I'm going to do it like this. 15x cubed plus 20x squared. And then what I'm going to do is say that I want to put it in factored form. Because right now this is in standard form technically. Let's put it in factored form. And what I'm going to do is this. How did I get it into this form, by the way? I'm just wondering. I distributed it. I multiplied. I multiplied it all in. Are we cool? I multiplied this number all the way in. So what I should do to factor it... By the way, people online, you guys aren't answering my questions.
Yeah, guys.
Yo. Yeah. Yeah, we're going to go up to 11, though. All right. Well, we're going up to 11 just because, I don't know. I put a note on my door, and I told all the teachers to send students down who were looking for me down to 205. All right. Anyway. Here, check this out. Ready? How do we factor this? How do we take this and factor it? What we're gonna do is we're gonna try to pull out as much as we can. So if I have the numbers 15 and I have the numbers 20, what is the biggest number I can pull out of 15 and 20? 5. Yeah, Paige, there's no point in sending me private messages. I'm sorry.
Just cover the Elmo or whatever it's called.
No, this is the chat, you mean?
No, cover the screen so we can see it.
Oh.
Cover your screen.
I don't understand what's going on. Anyway, I can pull out a 5. That's the most I can pull out. Now Nala is suggesting that the most we can pull out is an x. And I would, yes. What I'm saying here is, in the first term you have x cubed. In the second term you have an x squared. What is the most amount of x's I can pull out? 2 of them.
Yeah.
So I pull out an x squared. Are we cool? Yeah. And then what you do is to factor this, you just go like this. If I pull out a 5x squared out of that first term, what's left over?
Left with
3 and an x. Yeah? And if I pull out a 5x squared out of this one, what am I left with? Exactly. There, we factored it. That's factoring. Yep. That's what we're doing. You guys are having fun. All right, fine. Fine, have your fun. All right, I'll tell you what. I want you guys to work on this together. You guys can work on it together. Work on, in fact, go to this lesson right here. All right, go to this lesson right here. And for those of you who are online, you guys can do this. For those of you who are not online, just work on it together. Work on it in a group. It's right in your homework. Work on problem number 2.
Page 4.
So for those of you online, type in what is the greatest common factor? What is the biggest number I can pull out of x squared plus 5x? It doesn't need to be a number, by the way. And then type in your answer over here. And if you have discussion, if you need to discuss it with your, this is number 2 on page 4. Yes, Nalu, you can send it to me. You don't even need to send it private. You can just send it to me. In fact, do you guys want to do this Google Doc thing, or are we? Fine. I just figured I want to provide a forum for the online people to be able to work together. Like the fun thing about coming into class is you guys can work together as a group with other students. Anyway, I'll tell you what. I'm gonna throw this out there, Ben. How's this? Let's just do. In fact, everything that's circled in red is all your homework problems.
Okay.
So don't circle things in red. It's pretty much going to be all of them.
4, 2, 5, 3, 6.
Everything. There's a lot of red. You can see a lot of red things circled. So here, I'll do some of your homework for you. Let's talk about this one. Ready? What is the biggest thing I can pull out of x squared plus 5x?
An X.
I can pull out an x.
You can pull out a 1x.
All right. If I pull out an x out of the x squared, what am I left with?
You're left with
An x. If I pull out an x out of the 5x, what am I left with?
4x.
5.
4x.
No.
Minusing x.
I'm not talking about subtracting an x. I'm talking about dividing out the x.
Oh, he's literally getting rid of the factor. It's 5. Fine, it's 5. It's 5.
No, yeah, exactly. I mean, think about this. Look, watch. If I were to factor this thing back in, this would be x squared, right? Plus 5x. That's exactly what my original was. Look, factored form right there. You guys understand this? All right. Look at this one right here. Oh, whoa. Look at this one right here. 48x7 y squared minus 36x cubed y. Dang. All right, what's the biggest number I can pull out of that thing? Number 5. What is the biggest number I can pull out of this problem? Can I pull out a 12? I can pull out a 12. I'm just talking about the number. How many x's can I pull out? 3 at the most. Okay, fine. How many y's can I pull out?
1.
There's my GCF. That's the greatest common factor. And I put a parentheses. All right. If I divide out 12x cubed y out of the first term, what am I left with? What's left over?
4x.
4 with 4 x's. And how many y's? 1 of them left over. We cool? Alright, now I still got the minus. If I pull out 12, if I divide out 12 out of 36, what am I left over? 3. What about my x's? If I take out 3 x's, what happens?
0.
Well, there's nothing left, and y. And that's it. Factored form, suckers. No. No, see, the thing is, look. Don't write 0. Don't write 0, because you guys are telling me, oh, put a 0 here. Right? If you put a 0 there, then it would be 3 times 0 times 0, which is just be 0. And that's wrong. What we're doing here is we're not subtracting out these numbers. We're dividing out these numbers. So it's almost like, what is x cubed? Seriously, yo. What is x cubed divided by x cubed?
X. Nothing.
It's not 0. Ted, put it in binary. What is x cubed divided by x cubed?
3 divided by 3.
It's 1. You guys were telling me x. X cubed divided by x cubed is x over x. These cross out, and you get 1 divided by 1, which is 1. It's the number 1. It's not 1x. It's not 0. It's 1. Does that make sense?
Yeah.
Does it make sense, really?
No.
Oh. No, I'm sorry, I don't. Alright. Let's change that. Ready? Are we cool with that? Like, you guys understand how to do this? Greatest common factors? Alright, cool.
Wait, the number 6 is...
Fine, let's do number 6. You gotta pull out the same number out of all 3 of these things. What is the biggest number you can pull out? The biggest number. I agree. It's 1. There's nothing you can pull out. There's nothing that's the same. All right. What about the x's? What is the most amount of x's you can pull out? 2? You can pull out 2 x's out of everything? No, it says none. Are you sure? I agree with Nalu. Look at it. Look at it. Look at it. Why can you not pull out any? Nalu, why?
Because there's no other 3x squared. Or 3x cubed.
No. What? We know that. Don't worry about the numbers anymore. We decided that you can't pull anything out of there. What about the
Why?
x's? Nalu is saying because they don't all have x's. Or to the 5th power. So you can't pull out x's out of a 5z to the 5th power. There's no x's in there. I can't pull it out. All right. What about y's? How many y's can we pull out? None. How many z's can we pull out?
None.
So put this in factored form. There, that's factored form. Why are you lost? Yeah, I know. And the other ones, you were only pulling it out of 2 numbers. In this one, you have to be worried about all 3 numbers. And the answer is, the factored form of this looks exactly like the actual problem they gave me. And that's it. You can't factor it. That's the answer. You can't factor this. It's as already as simple as it gets. It can't be like, you can't, there's nothing that it has in common with each other that you can pull something out of. Are we cool? So one answer would be you can't factor it. There we go. Deal with it. No, there is a solution. What is the factored form of that? There's the factored form. It's just, It's exactly what it is. It's kind of like this. What is the factored form of this? X plus 5.
I don't know. Nothing. X plus 5.
It's x plus 5. Well, you want me to simplify that any more than I can? I can't make it 5x. What do you want? It's still x plus 5. That's the factored form. Do you get it? It can only be put in factored form. It can only be factored if there are numbers that are in common between the two, or between all of the terms. And there's no numbers that are in common between all of these terms. So therefore, no factored form. Does that make sense?
Yeah, it does.
So the answer is don't answer it, or just say it's the same.
Rewrite the thing.
Yeah, or rewrite the problem. All right, I'll tell you what. You guys ready for this next part?
Question.
Because I think it's kind of cool. Yes. What's your question? You guys want a break?
Yes.
I'll tell you what. I would rather get through as much as I can and then just finish like 10 minutes early. Which only means that I lecture for another 15 minutes and then class is over. I have class at 11 o'clock, so I got to go and teach that class. No, they're not coming in here, so I got to move all this stuff upstairs in like 5 minutes. All right. Here, I'll tell you what. I'm going to give you some numbers. I want you to memorize these numbers.
No. You said you want to make us memorize it. It's not how you deal. You don't pull equations out of your butt.
All right, fine. You know what? I didn't memorize this, and I still don't really have this memorized. But what I'm saying is, I'm going to show you some numbers. I want you guys to tell me how you could memorize it. How's that? 1, 4, wait, 9, 16, 25, 36. Look at the numbers. 49. When you see these numbers, I want you to say, hey, that's a part of this special set of numbers Mr. Balde gave us.
Okay, that's part of the special set of numbers. Mr. Dalton.
All right, well, what's the next number? What is special about these numbers that I'm showing to you right now? I'll give you another one. 64. What are they? What's the next one? What's another number? Give me another number that's a part of this list. 81. That's right, suckers. What's the next one? 100. What's another one? These guys are killing it.
Keep killing it. You got this.
121, actually. 144. There we go. All right. The twins got it. Ted's got it.
Yeah, twins.
Where are we getting these numbers from? Did I really go down and memorize these numbers?
Not man.
No, I didn't. I didn't actually memorize these numbers. Remember, I told you. You're right. I told you. Don't memorize them. But I'm just saying. Exactly, Ted. Ted's saying x squared. Think about it. What is 2 squared? 4. What is 3 squared?
Oh. Now, when you said squared, I was thinking I was like, that can't be right because 4 squared is not 9.
All right.
So I was thinking for the next day.
So have you guys learned these numbers? Have you, like, when you guys learn your multiplication tables, were these like special numbers that you guys looked at? Really?
Because
Well, I mean, essentially, like, if I were to show you like these numbers, were you able to identify them and say, "Hey, that's a perfect square"? Okay, this is what I want you to do. I want you to be familiar with these numbers, and you guys kind of understand these numbers. When you look at them, you're just like, "Hey, there's something special about that number." Okay? All right, cool. Now I'm going to show you guys something else that's different, but I want you to keep in the back of your head that there's some of these special numbers. Write it down. Go for it. Are you ready? I'll move on there. Oh, come on. You guys can figure it out. See, that's the thing is... All right, here, let me try this. Ready? multiply this out, and do this on your scratch paper. X plus 7, x minus 7. Let's do it. In fact, I'm going to do it on the side over here. X plus 7, x minus 7. How do I multiply that out?
Wait, where?
This one right here. I FOIL. First outer and last. So that's x squared minus 7x. Write this down, you guys. Plus 7 minus 49. 7 times 7, 49. Then what happens? We're on the bottom of page 4. Then what happens? Oh, I'm sorry. There's an x over here. Is it negative 14? What were you saying? What about it? All right, so what John is saying is negative 7x is going to kill this positive 7x. Are we cool? And so you're going to be left with x squared minus 49. What do you notice about the 49? It's a perfect square. It's 7 times 7. We cool? I just want you to notice this. All right, you ready? All right, let's try this. Let's try this one. Ready? X minus 6, x plus 6. Let's multiply this out. X squared plus 6x minus 6x plus, or I'm sorry, not plus, minus 36. We cool? I just FOILed that. First outer and the last.
Yep.
Are we good?
Yep.
All right, now what happens? These guys kill each other out. And so I have x squared minus 36. What do you notice about that 36? It's a perfect square. You guys seen a pattern to this thing? All right. Okay, well, what is this one? All right. This one is 9, or it would be 9x squared, right? Minus, what's 8 times 3? 24x plus 24x minus 64. And what happens? What happens? So you're saying that the middles cancel. So you have 9x squared minus 64. I want you to notice something here. Now look at this. Yes, this is in standard form. Huh? 9 is what? 9 is a perfect square. 64? 64? Also perfect square. So when you have, and listen to this, all right? I'm going to give you a formula. I'm not pulling it out of my butt. I'm actually kind of taking this from this thing. All right, what's your question? If you have a perfect square and you have a perfect square. All right. No. The reason why I'm thinking about it is because I would say no to your answer, Brandy. And Brandy asked, if you have a perfect square and you have another perfect square.
That was a joking question.
No.
Serious about life.
But there actually might be some truth to that. So I'm just trying to think. All right, anyway, let me get back to that. But anyway, check this out. Look, let's make up the rule. Watch. Let's make up the rule. You guys ready? If I'm given this form, I'm going to tell you right now, if I'm given this form, x squared minus 36, and I want to put it in factored form, it would be x minus 6 times x plus 6. Are we cool? Yes. Is there a rule that you guys can make up that will take it from this form and put it into this form? All right. No. I'm asking this to you seriously. If I have a perfect square minus another perfect square, is there a trick that I can use to get it into factored form? What is it? Okay. All right, so you're saying like instead of an x, what if I had an a squared minus b squared? You're saying that there would be an a here and there would be an a here, right? And you would put a b here and a b here, right? And what would you put in between that? What do you notice about the stuff? There's a minus on one. What about the other one? Write this equation down. Memorize it. And I'm saying I'm allowed to say memorize it because I didn't just pull it out of my butt. You guys, no, it's not even that I wrote it down. You made it up. This isn't my equation. This is what John was saying.
John did it.
Yeah, we can call this John's equation from now on. Why? This is no longer the difference of squares. This is the JH equation. Yeah, that's right. I gave you stars and whatever. All right, no, check this out. Ready? This is called the rule of difference of squares. If you have two squares, and why do I have the word difference in there? What does that mean?
Because you can tell the difference.
Why do you think it's called difference of squares? You can see why this is called the squares part. No. If I want to find the difference of something, what would I do?
Oh, the difference of something. It's the amount of whatever thing.
So what would I do? Ted's got it.
Oh, yeah.
Yes. I would subtrace it. No. Right, so this is saying, here's the formula for a squared minus b squared. If you notice an equation, if you notice something is in standard form and you notice, hey, that's a squared minus b squared, then what you can do is you can immediately say that's a plus b times a minus b. Stop talking. Focus. Here, try these out. Try these on for size. Page 5. Look at this one. Try x squared minus 81. You guys do that. Tell me what you think. X squared minus 81, how would I write that in factored form? Factored form looks like this. What would I do?
I got it. Fix it.
No, I want these guys to. Randy, you just behind. Yeah, do the others if you want. You get it if you don't. All right, what do you get? What do you get? Tell me number one. You guys can shout it out. Go for it.
X minus 9. And then the other one is x plus 9.
Perfect. X plus minus 9 and 9. We cool? I want you to do a challenge one, though. I'm going to do this one. You ready? What is x4 minus 16? Try that. And this is a separate one. This isn't on your homework. This is a different one. x4 minus 16. And I'll tell you what, after you're done with this, I'm going to end class. And I didn't even get to factored form. x4 minus 16. Blurt it out.
X squared minus 4.
X squared minus 4 times x squared plus 4. That's genius. Good job.
Brilliant.
You got it wrong, but it was genius. I'm just letting you know. You got close.
Thanks for like bringing me up to bring me down.
Yes.
That hurt.
What are you talking about?
That hurt.
No. I'll tell you what. Here,
I got it.
it's not necessarily that you're wrong.
It has to do with the x squared thing. Yeah?
It's that you're not finished.
Oh, not finished.
Does that make sense? It's not so much that you're wrong. This answer is wrong. It's that it's not done.
Wait, Mr.
I know. I'm not doing the number 4. I'm doing a separate one. I'm doing a different one.
You square the way outside.
What do you mean square the way outside?
Put a square on the way outside.
You mean
No, it's not.
like that? No.
No, not.
You said oh. What are your thoughts? No, you're on to something. Don't let anybody like shoot you down.
You got it.
Guys online, come on, I need your help. Why is this not
Come
done?
on.
What do we still got to do?
We're missing something in front.
It's not something in front.
I don't know. 4 times 4 is 16.
4 times 4 is 16, I agree.
We could do 1 times 16.
What you did here was perfect, but you're not done yet.
So is it x minus 2 x minus 2?
No, you don't have to foil it. To foil it, if you foil it, you'll get straight back here.
Oh, I meant.
We're factoring this. We're breaking this thing down as much as
We're
we
missing the
can.
negative in front.
No, there's no negative in front. You got this perfect. I'll tell you what. I'll even give you a bigger hint.
Just happy to tell us.
Look at that right there.
What about it?
X squared minus 4.
No, that's right. Maybe.
I'll give you a hint.
Wow. It was 3? Why? X. Okay.
John, I was asking for help, and you didn't. This is what you wrote down?
Why is it like that instead of the other one?
No. See, you got it wrong. That's straight up wrong.
Oh, so
Why?
Look. Yeah, what's your question?
Why is it in the x minus 2 and x plus 2 instead of just the x squared?
Because look. I told you that you can break down anything that has an a squared minus b squared, right? A perfect square minus a perfect square. This is a perfect square, right? And this is a perfect square. Wait, hey, no, come on. I'm almost done.
Asking a question about homework.
Yeah, I know, but I need to finish this because it's almost 11 o'clock.
Okay.
This is a perfect square, and this is a perfect square, so I can break that down. Agreed?
Why are you
Because we're factoring it. That's the point. Now, why can I factor this one down, and I can't factor that one down? Why can I factor this thing down even more? Because 4 is a perfect square. So you can keep going with that. Because it's a perfect square still. So you can break this down. Now, can you break this one down, though?
No,
No.
because you need that x squared.
No, the x squared is there. You cannot break this one down because that is not the difference of squares. This is the addition of squares. And there is no addition of squares formula. There's only a formula for the difference of squares, not the addition of squares. That formula does not exist. That doesn't make any sense. That's right. Yeah, everyone throw their pencil down. Yes, exactly. We're we need to subtrace the squares. Yes, exactly, Raimana. No adding, subtracing it. What?
I can't come on Friday, but I'll try to come on Wednesday.
Why, you guys actually like coming into class?
I like this. This is fun. I like it a lot. I miss doing this. It's more relaxed. I love the
I tell you what, I will try to see. I don't think we can have this room every time because this is actual classroom. We're just borrowing it because they're on a field trip, so we got to go clean it up. But I will try to hold a WebEx, or I'll try to hold a class where it's fun and interactive. And I'm going to make sure to do the online people as much as I do, like have fun with the face-to-face people. Although, to be honest with you, I think that when you come in face-to-face, it's just more fun. But I'm going to try to do it like these things. I need you to turn in your homeworks, though.
Homework is already plural. You don't have to say homework. Just say.
I need you to turn in your homework assignments. Because obviously some of you get it. You're just not turning in your
Why are you
homework.
making eye contact with me?
Because I'm not naming names.
Stop making eye contact with me.
I'm not naming names.
We essentially are naming Jonathan and Brandon. That is what's happening. You guys.
I didn't say I wasn't pointing fingers, but I'm just saying I'm not naming names. Well, I mean, you turn in your homework. You guys slightly turn in your homework. But you get it. Yo, all right, I got to go. What's up? Who's that? Fine, Ted.
It's always Ted. It's
Ted,
always Ted.
I can't click the link now. I actually have to go. But, Ted, I'll click the link when I get back into the class. Because I recorded it. All right.
Tom says it's not good.
Okay.
Oh, don't click it. I don't trust anything he says.
I'm not going to click that link.
Don't. If he says no, don't click it.
All right, let's go. All right, I'll see you guys later.
Appropriate, Ted.